I think the recording is on. So welcome to SQL Friday number 74, it is, with Ben Kettner, who is a returning speaker. Ben talked about T-SQL ninja skills last time he was here, and today is going to be, I think, quite different. It's going to be about time series data and the offerings you have in Azure, if I understand the abstract right. It might be totally off, but
we'll see where it takes us.
It's going to be 60 minutes of complete improvisation around time series data.
No, not complete improvisation. I did actually prepare some stuff.
Cool.
Unusual for me, but
before we start the presentation, will you be on Data Grill then, Ben?
Yes, I will.
Good.
But not with times. Well, there will be time series in my talk there as well, but differently.
I don't know how I should say this in a nice way. I don't care about the topic. I want to buy you a beer. That's all. So I'm going to be there as well.
Cool. Yeah. There I'll talk about creating the Internet of Hams.
The Internet of Hams.
Yeah, because I make ham in my free time. I smoke ham.
Okay.
And bacon, and I talk about how you can get digitalization into that kind of process.
All right, so then maybe
I might also bring some samples.
I will join your session then. Anyway, welcome.
Free food lures everyone.
Let's talk about time.
We offer free food
now.
Yeah, cool.
Whenever you're ready.
Yeah, I'm super happy to be here again, and since we're not that huge a crowd, and I'm happy with that. If anyone wants to comment or discuss or ask questions at any point, feel free to do so, because I always feel that having a conversation between more people is more interesting than just hearing one person speak for all the time. So anyone on this call, feel free to unmute and ask whenever there's anything you would like to discuss. So I'll start sharing my screen. Here we go. And I'll start my presentation. And since I know, Magnus, that you're also venture into music, I brought a musical quote here. So the first question goes to the audience. Who knows what song this is from? Very famous German band, not Cannibal Corpse. I remember that we discussed these the last time.
I mean, I could Google, but that would be cheating.
Yeah. It's fairly easy. And I like it because it somehow fits the topic of time is time again, and time. What is time? This is one of the central questions that I'll discuss. Maybe time series. What are time series? But let's get into this, and it's from Blind Guardian, from Somewhere Far Beyond, the opening track. So just a little musical detour that I like to take, those kind of detours. Okay, so what I've planned is I would first like to discuss a little bit what is time series data, because you hear people saying time series data, and I'm by profession, I used to be a mathematician, so I'm very strong on keen on getting clean definitions of stuff. So this is something I really want and that I really like. And if I try to talk about topics, I first try to grasp what is the topic we're talking about. What's the clean definition of that? So let me start with that, because defining time series is on one hand rather simple. On the other hand, it can be a bit tricky, and I'll give you some ideas of where it could be tricky. So first, this is time, as you can all see. Pretty obvious that this is time. And now, what is time series data? Well, throughout the time, we make a measurement of some data. And then we'll make another one. And as you can see, as we have 1, 2, 3, n data values measured across time, we have a data value measured together with a timestamp, and then those two together go as a time series. Now, the way I've I've shown them here is a bit suggestive in that I suggest that the data here is more or less evenly spaced. So I say, okay, I make a measurement every 5 seconds, then I have a series of data, and this is a time series. Now, the big question is, if I do this, and then have another measurement here, and then another one maybe only here, and have them more or less randomly distributed, is this still time series data? And there's some people arguing that it is, and other people arguing that it isn't. So this is really up for discussion, and you need to, if you talk about time series data, you need to make up your mind whether you only want evenly distributed measurements that are made on the clock by some automatism to be time series data, or whether you want to allow randomly distributed events. And I make the differentiation here between a measurement that occurs regularly and an event that happens if something happens, if an event occurs. Whether you want to regard both of these as time series data or not. And I tend to go with saying, for me, they're both time series data, because I say time series data, for me, what I see as time series data and what I like to work with and what I'll discuss later on is just data that is associated with some kind of timestamp. You have some value that is measured or occurring at regular irregular times, and I don't care about that. And most importantly, since at least I'm not able to travel back through time, unfortunately, it's append only. So you'll only have new measurements that are appended to the end of your series. So quick question to the audience, does this make sense to everybody? Or does anybody have a different definition of time series data that they would like to discuss?
No, I think it's good, and I agree with your definition, because regardless of if it's, you know, fixed intervals or not, you still have to handle that in a specific time slot. There might not be any data, even if it should be. So you have
exactly.
You have to treat them the same way anyway.
Yeah. Plus, I'd like to add another thought to that. If we have a look at time data and see time series as data related with a timestamp, related to a timestamp, then you could also say the kind of questions we ask from that data is the same, no matter whether it's evenly spaced or not. And I'll come to the kinds of questions that we ask of time series data in a moment. Now, next, maybe let's quickly discuss why is time data important? Why do we want to? Why is time series data even a topic? Why should we speak about time series data? And for me, why is it important? Well, IoT data, if you have IoT devices, any IoT device, whether it's consumer device or an industrial device, it will measure some kind of sensor value at some time. So you will automatically have a value measured associated with a timestamp. So you will have a time series data. And I don't think that I need to show those slides where you see the growth of IoT devices and connected devices and stuff like that. But beyond that, applications like monitoring and logging, not only of cloud solutions, but of course also for on-prem solutions. If I look at a log stream from a solution, that is also time series data, because I have a timestamp and a log event, an error event, anything. And that's a good example, in my opinion, of data that occurs irregularly, because the log events, the error events, hopefully don't occur on a schedule. If they do, we might need to talk about your application again, but usually they'll occur more or less infrequently, randomly, but still they're events associated with a timestamp. And so by our definition that we just agreed upon, they are time series data, and they're important to work with, because any one of you who's ever worked with application insights or maintaining any solution, be it on-prem or in the cloud, had to work through logs of your system and query the logs of your system and find certain log entries that are of interest to you. So maybe here the importance is also clear. Why is it important that we have solutions that are able to deal with that kind of data? And the third example is one that I'm not a financial mathematics guy. I'm not too keen on finance stuff. It's just not my main area of interest. But if you think of financial transactions, usually the transaction has value and a timestamp. So these are also time series data, which also makes clear why this is significant, a significant topic that we should talk about. Now, all three of these examples can not always, but can have something in common. And the thing is that most of them will have high volumes of data. If your application has low volumes of logging data, probably nobody's using it, then maybe we can factor that out of the equation. But usually if your application if you're logging an application and this has a certain load of users using it, you'll have a high volume of log data that you need to store, that you need to process. IoT data just the same. You can measure at sub-second intervals, at day intervals, but usually you'll have high volumes of data that you're measuring. So there's very often high volumes of data or data produced at high speeds, high velocities. Also a part is often also a part of time series data, and this maybe this is also justification why we should at least discuss how we want to process, store, and query that data, because having high number of connections, putting data into a certain sink can, as most people who've worked on a transactional SQL database know, lead to certain challenges. So I think that's also another argument why it is important to think about how can we process, how can we store, how can we work with time series data also in the cloud area. So this is why also pays straight into the question, why do we need special data storage, or why might we need special data storage, special databases for that? As well, if we think about sensor measurements, you'll have one kind of sensor that sends a timestamp and a certain shape of data, and the shape will always be the same. So if we are aware of that, and if we make that, say, my data point, my entry has a timestamp, has a value, and has certain attributes, and they're always the same, I can achieve rather high compression rates on that data. So it might be good to take advantage of that shape of data, to take advantage of what we know about that data when we think about how we store and query it. And this is what I already hinted at in the beginning. We often have very similar types of queries. So we say, okay, what was the value at a certain point in time? So we want to retrieve a single value. The latest value, what is the current temperature at? And intervals where we want to aggregate. What's the average temperature in that room yesterday, last week, last month? So these are typical kinds of queries that we will ask when we query time series data. So all of these queries typically have some connection to the time column. Let's talk relational, since this is SQL event today. Let's say relational. We query the time column, and we query either single values of the time column or aggregates over this time column, usually when we query time series data. And if you think of a time series data as the measurement goes on, it's an ever-growing table. Of course, we'll need to think about that in the application case. It will not be indefinitely growing. We need to have some retention policies or stuff. But what will happen, it's a growing table, and usually you'll try to, or you'll expect to have a good response behavior when you ask those special aggregates. You'll usually not query the entire history of something. You'll not say what has been the temperature in this room ever since we started measuring, but you'll usually say what was the maximum temperature, the average temperature yesterday. So that's also something that's rather typical if you work with time series data. So now I've given a brief idea of what time series data is, why it is important, and why I think we need to think about how we store time series data and how we work with time series data, especially in the cloud area. Has everyone dropped off, or is someone still on the call?
We even have people coming into the call, so it seems like you're doing a good job.
Well, they don't know what they're going to hear when they just join, so time series. Well, another time series that points in time when the people joined this call. Great example. No. So maybe this signifies why I think about time data a lot. And in our company, you cannot see it here because my office is on the top floor, but we do a lot of IoT stuff. We build our own sensor devices, we have hardware production, and we work with time series data on a daily basis. So this is something that I see actually on a daily basis and I work with on a daily basis. So this is something that's very close to my everyday work topics. I should also add another disclaimer. I'm another reason for me to give this presentation and to start considering time series data and to think more about time series data is that I currently have a student colleague who's writing his bachelor thesis on benchmarking different time series databases and how you can measure the performance on different time series databases in the cloud, on different ways of storing time series data in the cloud. So this is also something that prompted me to get deeper into that topic and to look further into that topic. And we'll, in a few weeks, once his thesis is done, we'll publish the benchmark code as well as the bicep templates to create all the resources in Azure on GitHub repository to make that public as well, because I think that's also quite a cool topic to think about. How good is the performance for those different types of queries that we were talking about, query time series data. So let's talk a bit about how do we what options do we have to store time series data in Azure. Now I'll take this time. I'll just close the presentation and stop presenting and have a look in the call and see who can think of any, or what options would you choose to store time series data. If I give you the time series data, the definition of time series data, the kind of questions that we ask on time series data, what ideas would you have to store time series data in an efficient way in Azure? Maybe you go first, Magnus.
I mean, one option would be to store it in a SQL server, because I mean it's the tool I use the most. I would probably look at Elasticsearch, depending on what kind of logging data. If I want to be able to search in the values column, I would probably go for Elastic. If I want it for monitoring only, like create beautiful dashboards of metrics, maybe the tick stack, I don't even remember. Well, it's called InfluxDB.
Yep.
But I haven't looked very deeply into the topic, to be honest. So
yep, cool. I'll show a few other examples as well that work well.
Mm-hmm.
Does anyone other in the call have any tech stack where they say that will be something I would use to store time series data? I'm trying to learn as well, to get new input.
I see some people on the call who should have an idea about it at least, so don't be shy, people.
Yeah.
No. Or is anyone typing in the chat? I haven't looked in the chat.
No, I just opened the chat. We only had guesses for the song title for the song, and it's not Rammstein, not Papa Roach, but still. Okay, then I'll just give an overview. What I've prepared now is, okay, we have somebody typing. I have a set of a few options that I would consider typically, that I would like to. Yeah, timescale is also one of the options I'll show in a moment, but I'll discuss briefly and also try to discuss what it does, what is different, what happens there, and try to give an idea of why some I like better and some I like less. The pros and cons that I'll show are basically my personal flavor.
Mm.
So there will always be people that say, well, but SQL is the answer, or, well, timescale is the answer, but that's always a personal flavor, and it strongly depends on what you want to do with the data and how you want to connect to the data and everything. So I think there's always a lot of options that we can discuss, and so be aware that what I'll show on the next slide is always with a personal flavor of what I used, what I've had experience with, but still I'll try to give an idea of when or where I would use what. Okay, so I'll go back here, start presenting again. And now it's always the big question, will it continue? Yeah, it will continue. Okay, so Magnus, you already said Azure SQL database or managed instance SQL server. Always first go to, also for me. What's good about it, it's, to most of us, I guess, a well-known tech stack. It's available as platform as a service, which I like in cloud solutions because I don't like managing virtual machines and software and virtual machines and stuff. I'm just not an admin guy. Maybe there's people who just put their hands on their head and say, oh, what's this guy talking about? I'm not an admin guy. I don't like managing virtual machines. I prefer platform service whenever I can get my hand on them. Plus, the connectivity to an Azure SQL database is really good. It's really easy to connect to an Azure SQL database with a set of tools. It's easy to connect from an application using Entity Framework. There's so many options to connect to it. It's really a good stack if you want to connect to your data and work with your data. So that's really the pros of working with a SQL database, and I really like that. And so that's also one of the tech stacks that I always consider. However, of course, it also has downsides. Main downside, it's not optimized for timescale data from the start. So if you start with a blank Azure SQL database, you can add data warehousing schema and add data warehousing data there, and or time series data, and both will work equally well or bad, and you will most likely need to spend some time on index tuning. And if you're talking about data ingestion, you'll also need to most likely spend some time on, if you have many incoming data, high concurrency, you will also have to spend time on building a process that ingests your data properly. We all know this is something that can be done. And I know that there are many people on this call who already know how to do this, but it is an extra step that needs to be done if you want to do that kind of thing. If we want to query from a table with millions of time series entries, get the average of the temperature for yesterday, this will require an index. I mean, we're pretty clear about that, I think. And that's one thing. The solution that was just mentioned on the chat, the Timescale, I've put this here slightly different because I've put it as Timescale Extension for PostgreSQL, because basically that's how you would deploy it in Azure. I'm aware that on-premise there's also standalone solutions and everything, but you can deploy an Azure Postgres database and enable the Timescale extension on that Postgres database. The option to enable it is a bit hidden because you need to do it first, enable the extension in the portal, and then connect to the database and enable it in the database engine. So it's a bit tricky to actually get it set up. But it's totally feasible, and you will have a Timescale database in Azure with that stack. So this is a stack that has the advantage. Of course, it's relatively established. I mean, Postgres is not like something new, freakish, where you don't know whether it will be around in 2 years' time. So it's a rather established tech stack. It's also available as platform as a service, which I like. And with the Timescale extension, it is optimized for time series data. So this is quite cool. And what does it is optimized for time series data mean? Basically, what that means is that it has certain inserting mechanisms in place where it where it basically has tables to cache incoming data and then persist it into your table using triggers and stuff. Blackmagic, I've had a look at some of this, and if you look at it, it's quite clear what it does, but it brings that out of the box. Plus, it has the right indexes that you need to do those typical time series queries on the data. So that's quite nice because it works quite well with that kind of data off the shelf. So I use that quite a lot with 2 customers at the moment, 2 bigger projects at the moment, and so far I'm quite happy with how it works. So in the chat, I can't remember names. I'm awfully bad with names, but somebody wrote on the chat that you're considering it, but you're not sure about it. I would say at least give it a go. It's fairly simple to set up if you're doing it in the cloud. It's fairly simple to use, and the performance is actually quite cool. We had a scenario where we created all of this with Terraform, and the guy who wrote the Terraform script forgot to turn on the Timescale extension. And we saw like a factor of, I think it was about 250 in ingestion speed after turning on the Timescale extension. So it really has an impact if you work with that. So that's quite cool. Of course, it also has downsides. The downside is that if you use the Timescale extension on Azure Postgres database, Azure Postgres database itself does not support PG Bouncer, which is used for connection pooling in Postgres. As far as I know, maybe there's somebody on the call who can correct me on that. But I didn't get that to work quite the way I wanted. So this is a bit of fiddling required to get the connections, the number of connections up to the level you needed. And the second thing that it can be really annoying is that the Timescale extension is really specific when it comes to naming tables and columns. This is really painful because, for example, the Timescale extension does not allow for capital letters in your table or column names. Honestly. And if you create a table or column with...
Why? I'm sorry.
I don't know. I kept asking myself that thing, and I sat there, and it was really, really frustrating experience the first time I tried to set it up, because I created all these tables and I created them camel case like I do on the SQL Server usually. I'm aware that there was a discussion about naming conventions for SQL on Twitter this morning. But then I created that database, and I wanted to turn on the Timescale extension. Timescale extension kept telling me I wasn't able to find that table. I wasn't able to find that column. I said, well, but they're here. I can see them. They're there. I ran the create statement. I can see the table. It's there. And it kept failing and failing. And the trick is, if that happens to you, it's because you have uppercase letters in your column or table names. Yeah, this is a real bummer. If you stumble across that the first time, this took me days to figure out, and it was really, really annoying. But I sat through this and I managed to set it up, and after that it worked like a charm. But still, this you'll have to be aware that Timescale extension for Postgres database does not adhere to your naming conventions, but you adhere to its naming conventions. It dictates the naming conventions you're allowed to use. And exactly the question why was the question I asked myself. Maybe there's a workaround. I didn't find one. But be aware if you're trying that, and if you fail, just think, well, there was this weird guy from Berlin who said that there's a thing about naming conventions, and then have a look at this and try renaming your columns and tables. Yeah, there's a very, very simple option for storing timescale data that I use a lot because of time series data. All those times I get messed up. Time series data that I actually use a lot, and that's the simplest one, storage accounts. What I do if I have an IoT ingestion pipeline, the first thing I do if I get a message in the IoT ingestion pipeline is I store it to blob storage. I keep the raw data. Don't process it, don't do anything, just store it in blob storage to make sure that I have it persisted. And of course, that's a valid way of storing your time series data. And it's more than a valid way because it's a very scalable way. You can store years worth of IoT data in a storage account without any problems. It's really easy to handle, and it comes at practically no cost. So I really like that option for just dumping everything in. However, you need to consider a few things if you work with storage accounts to store your timescale data. Timescale, I keep coming back to timescale. It's that pretty lion that gets me back to tiger that gets me back to timescale all the time. Looking at that, I can't just resist but saying timescale. What you need to do is you'll need to think about how you want to store, partition, and organize your data on your storage account. Because if you dump everything in, the use of that data is very, very much reduced because you will not find the entries you're looking for. For example, for IoT, also if you have like IoT Hub has a storage account output, Stream Analytics has a storage account output. If you use these, what they do is they create structures year, month, day, and then they create growing files where they just dump in all the messages received. And what you'll typically want to do is say, what is the value for a given device? So you want your data, typically if you want to work with that data later on, you want it to be partitioned by device. And that's something that the standard connectors do not support. That's something you'll have to do yourself. And this is just a little caveat, take care of that because it's important. And now if we want to ask questions like what was the average temperature yesterday or stuff like that, of course, storage accounts don't have a native tooling for that, but there is a tooling that makes it fairly easy and that is really cool, and that's Synapse Analytics with serverless pools. I really like serverless pools for that end because you just add your external data source and you query your files in the storage account by just writing SQL statements, which is a really great option for getting the values out of the time series data. It's not fast as such, but it will work, it will do the trick, and depending on the speed requirements you have and the number of queries and the amount of data you have, this might be the cheapest option you can find out there. So that's also an option I find really cool. Of course, it's not optimized for querying, and you need the data storage strategy, as I just said. Yeah. So this is the third option that I could come up with. Now, the fourth option, Magnus, you mentioned Elasticsearch.
Yep.
Since I'm on Azure, I tend to not use Elastic, but rather Azure Monitor and Application Insights. And if I do that, then there's the product basically related to that. That's Azure Data Explorer. Have you had a chance to look at that yet, Magnus?
No, sadly, I work mostly with clients who either by legislation or by other reasons are on-premise. So yeah, for me, Azure is not yet a business case, but more something I do. Yeah,
I'm very happy that I have the chance to do a lot of cloud stuff because I enjoy that a lot. Azure Data Explorer is actually a pretty cool tool. It's really neat. It's an internal Microsoft product that came from the need of analyzing log files. So it's inherently built for working with time series data, which is quite cool, and it's really, really good at that. So this is really good. It works really well it's really fast. If you say like, give me the log, the average of the temperature entries for the last month, it will just go like that and query that data, and it typically will be very fast. So it has a very good caching mechanism. It has very good ideas of how to query the data. I'm also planning on maybe doing a session or two on Data Explorer in the future because I've started working with it and I find it really attractive and a nice tool. I haven't gotten around to do that yet, but at some point I most likely will because it's a really cool tool to work with time series data and to work with large volumes of data as well. The downside is the query language you have to use is Cousteau, so not SQL. As far as I know, for example, there's no support for entity framework connectivity to Data Explorer. So if you want to integrate it in another software, in another solution, it gets a bit tricky. It's a bit more work than if you work with a SQL database or even with a Postgres database. So, and it has quite a cost barrier. It's not a cheap service. To get a reasonably sized Data Explorer instance running is several €100 a month, at least. For that money, it can query and process large volumes of data, but still there's some upfront cost here to get that up and running. It's not a really cheap solution. For example, if you talk about Azure SQL database, you can go with a serverless tier and they actually start at €0 cost per month if you're not using it, and scale up with the use. For ADX, there's a baseline that's quite high. Yeah, so that's Azure Data Explorer. Now, two options. One of them was also already mentioned. That was InfluxDB. InfluxDB is one of the most popular time series databases that's around at the moment, at least from what I found and what I've heard and what I've used so far. And it looks like it has one of the biggest communities that there are, if not the biggest, if you exclude the Timescale Extension and only talk about specialized time series databases. So it's really a dedicated tech stack for working with time series data, meaning, as we discussed before, for the Timescale Extension, it has certain tooling, certain mechanisms that help you ingest the time series data, work with this append-only idea where you only grow your table, you only extend your table, and you have your table ordered, and you have indexes to support the queries that you like to do. It offers all that. However, it has one major downside that I'm actually really not keen on. As I mentioned before, it's not available as a managed service. It will always be deployed, even as in farms, if you deploy it in Azure. There is, I think, a service offering from the, I'm not sure if there's a service offering from the Influx people themselves. I think I heard something like that, but I'm not sure. But if you want to host it in Azure, you'll end up with virtual machines, and you'll end up with something that you need to maintain and that you need to take care of, which can be a pain, especially as it can add to the stack to the tech stack that it might be on an entirely different tech stack than all your other services that you need to maintain, which can be a problem. But if you have that tech stack and if it works for you, then it's a cool solution for working with time series data. Only also in the cloud, you'll have to think about how does it scale, how do I need to scale, when do I need to scale up or out, and you'll need to take care of these things as well. And the last option that I would like to mention is also a time series database that is very popular. That's the Open Time Series database, OpenTSDB. I stumbled upon OpenTSDB in a project where I was asked whether it was possible to set that up in Azure, and we did it, and we ended up with like 4 VMs for that setup that the customer wanted. We tested it, we tried to work with it and everything, and it's great. It's a dedicated tech stack just built for working with time series data. It has great data compression rates. It has great read speeds and everything. However, again, same as for Influx, it's something that's not available as a managed service. That's something that you'll need to manage yourself, and you need to be aware of that if you choose to go down that path. Yeah, so basically these are the different options that I've seen and used so far when working with time series data in Azure. And so it's like an overview. I'll stop the presentation and go back to Teams.